All right. Today we are doing section 10.1, and it is over the areas of trapezoids, rhombuses, and kites. So let's just go ahead and start out with the area of a trapezoid. It is 1/2 h, which again is the height. You need to write that down. Okay, and then our two bases, so B1 and B2 are both bases. All right. You could switch these. This could be B2, this could be B1. That doesn't matter. However, the bases need to be parallel. Okay? All right, and then we move over here to the area of a rhombus or a kite, and we have 1/2 times the product of the two diagonals. All right, so let's go ahead and just try one. The area of a trapezoid. Again, when we deal with height, I forgot to mention this, but when we deal with height, it needs to be the perpendicular distance from the two bases, or between the two bases. All right, so looking at this, our 18 inches is perpendicular to both bases. All right, so that is going to be our height. And then we have a B1 and a B2. Again, it doesn't matter if you want to put B1 on the top, that's fine. Okay, so let's put it in our formula. Area is equal to 1/2 height times B1 plus B2. All right, so we have the area is equal to 1/2. The height right here is 18. Then we have B1 plus B2. So we have 36 plus 20. Do you see now why that's not going to matter? 36 plus 20, 20 plus 36, it's the same answer. So the area is then equal to 1/2 times 18 times 56. Okay, so then the area is equal to 1/2. 18 times 56 is actually 1008. Okay, and then our area is going to end up being 504 square inches, or inches squared. Again, all we did is we identified our three parts, and we plugged them into the formula and solved. Okay, let's try a little bit different one. In this one, they don't give us the height. What they do give us, though, is they give us two bases and the other side. If it was this side, it'd be the height. Okay, but we're going to use a right triangle to find the height first. Okay, now the only logical place to draw a triangle in here is right here. Okay? And that little line that we just drew is actually going to be our height. It is the perpendicular distance from base 1 to base 2. All right, so now we have to figure out how to find that height. Okay? First of all, if I cut this in half right here, what figure does this make? What kind of quadrilateral? Okay, it is a rectangle, which means from here to here should be what distance? Should be 11 feet, leaving this distance here, what? 5. All right, so this side of our triangle is 5, and this hypotenuse of our new triangle is 13. So how do you think we're going to be able to find h? Okay, we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. Okay, our hypotenuse is always c. So we're going to go ahead and do h squared plus 5 squared equals 13 squared. And then we can go ahead and solve for h. Okay, h squared plus 25 is equal to, anybody know what 13 squared is? 169. Okay, subtract 25. H squared is equal to 144. Take the square root of both of those. Hopefully you remember how to do all this. So h is actually equal to 12 inches. This new value is what we're going to use then to find the area. We still have to find the area. But now we're going to do area is equal to 1/2 times 12, that is our height, times 11 plus 16. Our whole base is 16, so we have to use the whole thing. Alright, then we're just going to go ahead and solve. The area is equal to 1/2 times 12 times 11 plus 16 is 27. Okay, so the area is going to be equal to 1/2. 27 times 12 is 324. Okay, divide that by 2 or multiply by 1/2, and the area is going to be equal to 162 square feet. That is your final answer. Okay, so go ahead and flip it over. We're going to keep going here. This time we have the area of a kite. Okay, so let's refresh our memories here. The area of a kite is equal to 1/2 times the product of the two diagonals. Okay, so let's look first. D1 is equal to, doesn't matter which way you do it, D1 is going to be equal to 3 plus 3, which is equal to 6 centimeters. Then we have D2, which is going to be equal to 4 plus 1, which is equal to 5 centimeters. Okay, they give you the values of parts of the diagonals. I just have to add them up to find my two whole diagonals. Alright, so then I'm just going to plug it in. A is equal to 1/2, 5 times 6. That is going to be equal to 1/2 times 30, which our final answer is going to be 15 square centimeters, or centimeters squared. Okay, now the same formula applies to a rhombus. So let's go ahead and write it down again. The area is equal to 1/2 times the first diameter times the second diameter. Now here's where a little bit of your quadrilaterals knowledge needs to come in, because they only give us one diagonal and one side. So what we're going to have to do is remember the properties of a rhombus. What are the properties of the diagonals of a rhombus? Okay, they are perpendicular. And since it's a parallelogram, they bisect each other. All right, so we're actually going to have to draw in the other diagonal here. Okay, so that makes this part of this triangle, this part right here that I'm highlighting in purple, what value? If it bisects this diagonal, okay, it's actually going to be half of that, which is 12. Now, since these are perpendicular here, we have formed ourselves a new right triangle. So I'm going to go ahead and draw it out over here so it's a little easier to see. Okay, we have our hypotenuse is 13. Our long side is going to be 12. And what we're looking for, which is going to be x, is our short side. And once we find that x, because the diagonals bisect each other, we can multiply it times 2 to get the other diagonal. All right, so we're going to do x squared plus 12 squared equals 13 squared. I just plugged it into the Pythagorean theorem. All right, and 13 is my hypotenuse, so it always acts as c. So x squared plus 144 is equal to 169. Subtract 144 from both sides. Then I have x squared is equal to 25. Then we take the square root, and x is equal to 5. Now, x is equal to 5, but what is our other diagonal going to be equal to? 10, right? 5 here and 5 here. So we're going to go ahead and label those. Diagonal 1 is going to be equal to 24. And diagonal 2 is going to be equal to 10. So now we're just going to plug it in. The area is equal to 1/2 24 times 10. Area is equal to 1/2 times 240. Then the area is going to be equal to 120 square feet. And that is your final answer.